1, action.
All right, so the question we did was 13.2.8. The question asks is this function in L1? So we're going to start off with the definition of L1. So given some function f, we have to show that the integral of f, the norm integral, is less than infinity. So we're going to change these bounds. Instead of negative infinity to infinity, we're going to do 2 times 0 to infinity. Because the function's odd, we can do that. Our next step, if we take a look at the function, we know that this function is always going to be 0, either when cos of x is 1 or when sine of x is 0, which is at intervals of pi. So we're going to do a sum.
Okay, so now we have a function on the numerator that is non-zero within this interval, and since it's a continuous function, we know that its support has to have a measure of non-zero, which means that the integral of this thing is positive. So we know that there exists some epsilon greater than 0 for which this sum is greater than or equal to, and I'm just going to drop the 2 because it's extra baggage, the sum of j equals 1 infinity of the integral from j minus 1 pi to j pi, sorry, I forgot the epsilon, of 1 over x dx. So now we notice that we have a decreasing function on this interval, which means, if we draw this out, that taking some arbitrary interval that is defined j minus 1 pi to j pi, this function is always going to be greater on that interval than 1 over j pi, and the width of this interval is going to be pi. So that means that this thing is greater than or equal to the epsilon times j equals 1 to infinity 1 pi times 1 over j pi. The pi's cancel, and then this is equal to epsilon times the sum from j equals 1 to infinity of 1 over j, which is the harmonic series, which means that this is not less than infinity, which means that our function is not in L1.
Hello there. So, yeah. So let's keep this going. So we're gonna show that this that this function, that the limit of this function is equal to pi over 4. Well, from our notes, we know that the limit of this function, sorry, it's taking a while to write out. You can just speed this up, but not really, you can't edit. We know that this function converges, and the function that we have kind of looks like this one. So like maybe this one converges too. Well, let's see if we can make this thing look like that and find its limit. Okay, keep going. So because this thing is odd, wait, oh, I messed up. Sorry, this should be a negative R. Yeah, okay, moving on. Because this function is odd, we know that like, if we take the limit from 0 to okay, I'm going to show you and then like explain what I did next. Wait, I didn't pick this song. This guy's gonna kill me. Oh, no. Why is there a dB? Oh, because it's an integral. I forgot. Okay. So basically, to explain what I just did there, because this function is odd, we can take the we can change the bounds to be strictly from like 0 to infinity, and then add on the negative component of this function, rather than taking the whole, because the function kind of looks like this, right? So rather than doing the complete integral, we take the positive part and then add the negative part onto it, which is what we did right here, and then we just changed our bounds. Does that make sense? Okay, so let's keep going. Next, we're going to factor out a 1 minus cos pi v over v. Know that like, because cos is odd, we know that cos of negative x is equal to cos of x, right? Therefore, we can say this next. This is not a good take. But, I'm just gonna write out this thing. Okay, so you're probably wondering, like, oh yeah, this man factored out the 1 minus cos pi v, but where'd this thing come from? Well, from what we learned in complex analysis this year, applying our knowledge, looking at this term, we can equate this later on to sine 2 pi dt, right? So I basically multiplied and divided by 2i so that I can have this term, which I can equate to sine 2 pi vt, which makes life easier because we're slowly getting, something that's closer and closer to what we want up here. So from here, we can say this. Remember, I times I is just -1. over v dv. Okay? I'll just erase this so you have a better view of what we just did. See, now we're getting somewhere, right? You know, it kind of almost looks like this, but we have a 2 pi vt here and a you know, just an x here. So maybe if we set t to be 1/2, we can drop that too. So let's set t to be 1/2. Okay, now we're really almost there, but you know, at t equals 1/2, what is this integral equal to? Well, as Jonah pointed out earlier, by the Dirichlet's test, right? If f at t, like, you know, okay, so our t naught here is going to be 1/2, right? So if f at greater than t naught exists, and if f less than t naught exists, and the same for f prime, we can use the Dirichlet's test to find what the integral of our function will converge to. Yes. So looking at the graph, remember that, like, initially we said that, like, this function kind of looks like this one. If we look at the graph of what this function converges to, which is something like this, right? Where this is 0 and that's 1/2 and that's 1, right? We have, by the Dirichlet's test, we have equal to 1/2 f of t naught plus f of t minus, right? And f of t naught is -1. And f of t minus, right? I mean, f at t, like, sorry. F at t naught, like, greater than is, okay, yeah, is going to be 0.
He's approaching from.
Oh, yeah. So, like, you have -1 over here, and you have 0 here, and if you compute this sum, you get -1/2, right? Therefore, our integral here is equal to -1/2. So we're very close, right? Now, if we change the variables here, if we set x to be equal to pi v, right? If we take the derivative dx over dv is clearly, you know, equal to pi. We now have this. Cos x, right? Sine x, right? What did I say again? Pi, and that means that dv is going to be equal to dx over pi times dx. Right, this pi came from dv, this pi came from replacing v with x with pi over x. Pi's cancel out, and we now have 0 to an r 1 minus cos x times sine x over x dx equal to -1/2, right? And we're asked to prove that it's equal to pi over 4. Whoa! Sorry. Applying the limit. Oh, this is so bad. Limit as r goes to infinity. Yes, so applying the limit, we can see that if we bring this pi over to here, you know, we'll multiply both sides by pi, we get pi divide out this -2 on both sides. You get over -2, which is equal to pi over 4, which is what we have here, and we're done.